Okay, guys, may I have your attention? So let's go over the warm-up for today. Before we start, you have the equation. Tell your partner beside you what is the rate in your equation.
The rate is 2.5.
Okay, what's your rate? Bird, what's the rate?
2.5.
2.5. Now, how is this the rate? I know this is the rate because it's a coefficient of n. In your rate in a linear relationship, Stevie, is always going to be a coefficient. So if you thought 40 doesn't have a variable. It can't be a coefficient. So what is 40 then? Talk to your partner. What's 40?
40 is the y-intercept.
So I heard 40. 40 is your y-intercept. And n is your independent variable. A is your dependent variable. Knowing that you have two variables landing, right? A and n. What's your first column? Is it A or N? It's N. My independent variable always goes first, so this would be N, that would be A. I need to have variables at the top of my table so I know what those units represent. So here's the question. I asked you to make a table that is not repeating, that is in ascending order, so the smallest number's up top, the biggest number's on the bottom, and it's more random than what we've been doing. So, in a table, Tristan, first number I pretty much always want to start with. 0. Why 0? What does 0 give me?
It gives you your y-intercept.
Y-intercept. So putting 0 into this equation, I get 0 here, I'm left with 40. Okay, now let's get a little bit more random. But not too big, too fast. Yes? 3. I put 3 in. Do you have 3? Because I don't want to do all this math in my head.
Yeah.
Okay. So what'd you get? I get 3 times 2.5? 47.5. Good job.
7.
7? Okay, we'll do 7. What'd you get, Shannon, when I put 7 in? What came out?
57.5.
Nice. 57.5.
15.
Okay, let's even go. Yeah.
22.
Yeah.
What if you accidentally put the bigger number kind of shuffled in?
Yeah, we want it to be. That's what ascending means. Ascending means that smallest number is first, bigger numbers on the bottom. It's in order from smallest to greatest. So that's why I go 15. What'd you get? What'd you get for 15?
77.5.
What is it?
77.5.
77.5. Excellent. And then one more. 32?
Yeah. Oh, I have 32.
32. I put 32 in. It's still ascending order. I put 32 in. What comes out? 120. So, my last question. We got our independent, dependent variables. What could these variables represent as for units? Talk to your partner. Like what's n? What's a? What could they be in units? Now, if it was distance and time, would they be a and n? No.
It could be number of shirts and amount. No. What starts with nuts. And the amount. How many hours you're working.
Okay, let's go back together here. Shannon, in terms of units, what do you think n represents in this equation?
It can be the amount of shirts.
Like the number of shirts I have. Good, yeah. So if I buy 3 shirts, it's going to cost me $47.05.
Accurate for today's standards.
But there's a setup cost for the, right?
Oh, for the 40.
That's the setup cost, right? That would make sense. And then my A, so if this is number of shirts, my dependent variable would be the amount I pay. So that would make sense. That's a good example. Questions about the warm-up today? Okay, please put your warm-up away. And get out your homework.